Okay, we can start. So welcome to this session about the semantic modeler, where we are going to find out if it's time to ditch the model administration tool. My name is Federico Venturin, and as can you see from the picture, I'm a full-time desperate father. And in my free time, I'm also a principal consultant at Ritmamid, an Oracle ACE associate, and a board member of the Italian Oracle user group. I'm based in Trebaseleghe, a small city in the northeast of Italy that nobody knows. So I usually say that I'm from Venice because it sounds better and it's actually really close. Outside of work, I like to play video games, travel around the world, and taste local food. Ritmamid is a globally recognized Oracle data and analytics consultancy. We specialize in data platform modernization, AI business optimization, Oracle software as a service, and analytics. We are a UK-based company, but we work with clients all over the world. And some of our clients include universities, government agencies, financial services, and many others who want to use their data and make the most of the potential that their data holds. So to understand what the semantic modeler is, we need to start from the semantic model, which is not a new concept since it's around since 2007. In Oracle Analytics, the semantic model is just a new name for the metadata repository, the RPD. The semantic modeler is then an interface that allows us to create and manage semantic models and represents an alternative to the model administration tool. The semantic model is at the core of Oracle Analytics. It's a metadata layer usually built by the IT that presents all the available information in the form of a star schema structure, which is easy for users to understand and interrogate. This structure is based on measures, the numbers that you analyze, and they are usually contained in fact tables, and dimensions, which provide context to measures, to attributes and hierarchies. A semantic model acts like a translation layer between your application and your underlying data sources. It contains 3 layers of metadata that build on each other and prepare data for users to query and analyze. And we can see here highlighted in green the 3 layers included into the semantic model. The physical layer defines the objects and the relationships that the Oracle Analytics query engine needs to write native queries against each physical data source. Then we have the logical layer in the middle, which defines the logical model of the data and basically specifies the mapping between the logical model and the physical schemas. And this layer hides all the complexity of the data sources and of your model. So all your calculations or your logic will be included here and will be hidden to end users. And then we have one more layer, the presentation layer, which adds a level of abstraction over the logical layer and provides the view of the data seen by the final users. And now we are ready to start talking about the semantic modeler, which is a browser-based alternative to the model administration tool, which is fully integrated into Oracle Analytics. And the main benefits of this new interface compared to the model administration tool is that developers are no longer required to install additional software because it's already available in your front-end interface. And moreover, it provides native Git integration to support multi-user development. We can see here the architecture of the semantic modeler. And behind the scenes, this interface generates semantic model markup language files. They are basically JSON files to define semantic model objects. But behind the scenes, these JSON files, this SMML, is translated into the usual RPD format once you have to deploy to your Oracle Analytics platform. So this component is still used. So as I already told you, SMML is a JSON-based markup language which describes the objects inside the semantic model. And a cool thing about it is that developers can export semantic models and then use their editor of choice instead of the web-based interface. They can use any text editor. And eventually, they can automate some tasks by creating scripts that manipulate JSON files directly. Here we can see an example. We can see how a semantic model looks like once exported in SMML format. So we have multiple JSON files. They are included into 4 main folders: physical, logical, presentation, and variables. And then inside each folder, we usually have 1 file per table. This is the granularity of the semantic modeler. Table or initialization block. Creating a semantic model is really straightforward. You need to use Oracle Analytics Cloud or the latest version of Oracle Analytics Server 2024. You have to log in to the homepage of Oracle Analytics, click on the Create button, and then select Semantic Model. You then have 4 options to create your model. You can start with an empty one. You can create it from a previously created RPD file or a zip file that you have. You can create your model from the repository, which is currently live in your Oracle Analytics platform, or you can create it by cloning an existing Git repository where you already saved an RPD, a semantic model using the semantic modeler. Now, let's have a look at the new capabilities included into the semantic modeler and what has changed into this new interface compared to the model administration. First of all, the user interface is totally different. If you are used to the administration tool, the first thing that you will notice when opening the semantic modeler is that you no longer have a unique view of the 3 layers at the same time. Now, the semantic modeler displays 1 layer at a time, and you are provided with a set of icons that you can use to switch between them. It's easy to use, but compared to the past, you will have to click a lot of times. And if you are used to the model administration tool, at the beginning, you will find this very annoying, or at least this was my perception of it. Then, connection credentials are no longer stored inside connection pools. Now you need to create dedicated objects to store your connection credentials. You have to create system connections. They do not live inside the semantic model, and this is a good thing because It means that you no longer have to encrypt the semantic model, and this make it easier to migrate it from one environment to a different one. Of course, you need to create the system connections on both your environments, but the process of migrating it will be easier. The process of creating initialization blocks and variables is slightly different now. Now you always have to create initialization blocks first, and then for each one of them, you can choose to add variable definitions. Moreover, the available types of variables is different. Now you can create static variables which correspond to the old static repository variables in the administration tool. So these are variables that you set up once, and then the value never change over time. Then we have global variables, which correspond to dynamic repository variables in the administration tool. So we can use an initialization block to refresh the value of these variables, and they are the same for all users. So there is a single instance of this variable, which is shared across all users. And finally, we have session variables, which correspond to custom session variables in the administration tool. So these variables will be initialized potentially in different ways for each different user. And another big difference compared to the past is that now initialization blocks are set to deferred execution by default. It means that they will be actually executed only when your variables are required. So if you are using a variable in a report, that variable will be initialized only when that report is executed. Otherwise, the execution will not be completed by the Oracle Analytics platform. And this is to improve performance, basically. And this is particularly valid for the OAC, where we are in the cloud, so performance are more important compared to on-premise platforms. Then data filters. And here, the most important news is that the identity manager is gone, is no longer available. Now, to define data filters, you need to navigate directly inside the objects in the logical and in the presentation layers. And in my opinion, it makes more sense compared to the past, because you are going to define your security rules directly against the objects where the rules will be applied. Moreover, you no longer have to create placeholders for application roles. And this is straightforward because now we are directly working in a running Oracle Analytics platform. So we can retrieve application role names directly from the server. We don't need to create placeholders, and this is good. We have a new lineage viewer. It allows us to explore mappings between the three layers in an interactive way. The only bad thing about it is that it's not possible to export this information yet. So it's a very nice feature to explore lineage information in interactive way, but we cannot export it. So we must connect every time. We must select the object that we are interested in, and then we can see this kind of information. But it doesn't work in offline mode, and we cannot export it. Last but not least, we have out-of-the-box Git integration. which should make sharing and concurrent development easier compared to the past. How does it work? So first, you create your semantic model. Then the owner of the semantic model has to create an empty Git repository. Then inside the semantic modeler, there is a Git panel that you have to open. Then you have to click on Start and configure the Git integration. Basically, you will be asked to provide the URL of your Git repository, and you need to create a Git profile to authenticate. So your username and password or a personal access token will be required. And then the tool will automatically deploy your semantic model to the Git repository that you specify. And this is the first step to set up the Git integration. Then each developer is required to create its own semantic model object and use the clone a Git repository option to connect and clone all the SMML files which are currently in your Git repository. And then all the members in the development team create and work using Git branches to add, update, and commit the files on their computers, and then pushes the commits to the remote repository. So we have a lot of new capabilities. There are several good news, but unfortunately, there are also some features which are widely used, but are not yet available in the semantic modeler. Data sources. The semantic modeler at the moment supports less data sources compared to the model administration tool. Only relational sources are supported now. If you are using EPM or Sbase as a source, now you cannot use the semantic modeler because it's not able to read data from these sources. Oracle is already working on this, and support for EPM and Sbase is in the Oracle Analytics roadmap. They didn't share a date, but it is in the roadmap. So it should be available probably in the next release. And then several utilities, such as the aggregate persistence, the rename wizard, and the repository documentation are not available. We have a workaround. We can export the semantic modeler using the RPD format and then open it with the model administration tool where these features are still available. Okay, it's time for a live demo now. So let me start from what I'm going to do now. I'm going to start from this repository. You can see this is a repository created using the model administration tool. You can see that we have all the 3 layers here. We have a logical model. It contains some facts, dimension, hierarchies. We have 3 subject areas. We also have some variables. And now I'm going to pick this repository, and I'm going to create a semantic model based on it. And then I'm going to show you how the Git integration works and basically how this new interface works. Okay, so let me open my Oracle Analytics environment. Okay, you should be able to see my screen now, so let me connect. So this is an Oracle Analytics Server 2024 server. Here I'm using the WebLogic account, which is the service administrator, basically. So let's create a new semantic model. We have to give it a name, for instance, with Mamed, and click on create. Now, I want to create it from the repository that I already have in my local environment. So I'm going to click on import a file. Okay, this is my file. So I'm going to upload it. And since it's an RPD file, it's still encrypted. So I have to provide a password in order to upload it properly. Takes a while. Okay, our model has been imported. And by default, the semantic modeler displays the presentation layer. So you can see we can use these icons to switch between the different layers. And if we double click on a specific object, all related details will be displayed on the right panel here. So this is my JCBC fact order line subject area. Here I can see the tables inside this subject area. If I click on a particular table, I can use this action menu to display more information about it or to execute some actions. I can also double click on it. It will open a new tab here where I can see all the details about the table. So I have my general tab here where I can rename it, add a description, and so on. I can review columns. I can define hierarchies. Now, hierarchies are included into each table object. And again, it makes more sense since they are created from dimensions, basically. I can handle permissions and other things. The bad thing about this approach is that if you keep opening objects, new tabs will be created. And it's very easy to get your page full of tabs. This will consume a lot of memory. And sometimes when you have a huge number of tabs, your application, your web browser may crash. So it's a good practice to close them when you don't need them any longer. Okay, now let's try to deploy this model. But to do this, first of all, we need to create the system connection because connection credentials are no longer included here into our connection pool inside the database object. So here I have two connection pools. I can display the details for them. And here you can see that I have a connection parameter, which says system default. System default means that there isn't a connection for it. So if I try to deploy this model and use it, I will get errors every time this connection is used. So I need to navigate back to my connection tab, and I have to click on plus to create a new connection. Here, the data are inside the same server where I installed Oracle Analytics. So I can create my connection and provide the details. Of course, you have to use the details for your own connection if you want to test this capability. Okay. You can see that now I have a connection here, and I can use this connection also to explore the available objects inside the schema that I specified. And I can drag and drop objects to the physical layer using this connection. You have to open your physical layer first. In this way, and then you can drag and It's a bit tricky at the beginning if you are used to the model administration tool, so it requires some practice. Okay, so I created my connection, and now I'm going to use it in my connection pose. So first one, details, connection, ritmamid. Save it. And let's do the same for the other connection pole. Okay. Now, we can run a consistency check to validate the repository. We can click on this icon here. Okay, and we can see that we got an error. And it took a while me to understand it. Basically, you cannot use all the characters that were available in the model administration tool when you create object names. Basically, here, the column character is not supported. So I have to remove it in order for the semantic model to be valid. So the presentation table is JCBC HR stores. So let's go to the presentation layer. JCBC HR stores here. And if we have a look at the presentation layer, we see that the error is actually not here because we don't have any column character, but is in the logical layer. And you can see that now I have dim HR stores. So basically, you will get errors about this unsupported character, but it's not written that the character is not valid. It's something that you have to derive from the message. And basically now I'm going to fix all these errors because they are not displayed. Not all the errors are displayed, just some of them. Let's do it. So let's remove this character, save. And now this one, general. And another annoying thing is that I cannot use F2 to rename objects directly here. I need to open a new tab, and then I have to click on the general tab, and then I can rename my objects. But this is more or less okay because it's a web interface. You cannot have all the functionalities available in a desktop tool. And then I have this one, general name. Okay. It's Spark as well. Okay. Okay, it looks okay. So let's run again the consistency check. An important thing to note is that this semantic model is offline. So I'm inside the server, but this object is not the live repository. So you can do all your development changes. Your end users will not be affected if you don't deploy it. Okay, so this time there are no errors, no warnings, so I can deploy it. And to do it is really straightforward. You open this page menu and select deploy. In a similar way, we can export it if we want to use a different editor to manipulate our JSON files. You can see that Oracle Analytics is deploying the semantic modeler. And here we will be notified whether the process completed successfully or not. Even if it completes successfully, it's a good practice to refresh your metadata from the administration page, just to be sure that all the tools are going to use the latest metadata. So the deploy is successful. And I should be able to create workbooks based on my subject areas. And I should be able to see my data here. So now I'm using a semantic model created with the semantic modeler as my live repository. Okay, now let's go back here. Now let's suppose that we have more users that need to apply changes to this object. We have two options. We can use the inspect option and we can share our object using permissions. It means that we can add to this page other application roles or usernames and then set up full control or read-write privileges for them to share our object. Or we can use Git, which is the recommended option. So now let's share this using Git. And to do it, the first thing that you have to do is to create a Git repository which is empty. And I already did it. So you can see here, this is my GitHub account. I created a semantic modeler repository, and it contains only one branch, default, which is empty. Now, I'm going to open my semantic model, and I'm going to click here on this Git icon to open the Git panel and enable the integration with Git. So I click on Start. Here I have to specify the URL of my repository. So here I'm using GitHub, but you can use any Git client. So let me copy the URL. Let's paste it here. We have to specify the branch name that we want to use to store our semantic model. And it must be a new branch, a new empty branch. So I cannot use default here because it already exists and I will get an error if I do it. I have to specify a new branch name. It could be any name, it's up to you. And then click on continue. If this is the first time that you are using Git, you will have to create a profile as well. Typically, each user should have a dedicated profile where you're going to use your username and your personal access token as the password. And then you just click on initialize and the tool will do all the job for you. Now, Git has been initialized. It means that if I go back here to my GitHub account, you can see that there is a new branch, main, which contains my semantic model. I have 4 folders, one for each layer in the semantic modeler, and the last one is for variables. You can see that it contains one folder per subject area or business model or subject area. And inside them, I have one file per each table. And you can see that in each table, I have the name, descriptions, if you added it, and then you have a list of columns with other details. Now, let's try to simulate multiple users which are working in a concurrent environment. For instance, I can try to rename a column and push this change to Git. Let me have a look. So I can go here in the presentation layer. And for instance, I can rename shops to store. Or I can rename, sorry, revenue target just to target, which is shorter. Okay. I save my semantic model object. As long as I do it, you can see that here into the first tab in the Git panel, some objects are marked as unstaged changes. So I have to click on stage all and then commit if I want to make them persistent in my local Git repository. And then I have to push my changes to the remote repository in this way. Now, if I go back here, I should be able to see that in my presentation layer, fact order line, you can see that name target instead of revenue target. So the column has been properly renamed. Now, let's suppose that there are multiple, I want to simulate a conflict, basically, to show you what happens when multiple users are developing together. First of all, we should use branches. So let's suppose that I need to do some implementation. So I'm going to create a new branch, and I'm going to call it dev Federico. Now you can see that the current branch is the new one. And let's suppose that I've been asked to change the description of this subject area. So double click, general, and let's call it, this is a description made by Federico. Okay, so let's save this. Again, some changes have been detected as unstaged ones. So let's commit them to my local repository. And then let's push them to my dev Federico branch. Now, let's suppose that at the same time, some changes have been applied to the main branch. So I'm going to switch to main. And let's suppose that by mistake, another developer changed the description of this object. This is a dummy description. So let me save it. Stage, commit, and push. This time I'm pushing the change to the main branch. Now, what happens? If I go to my GitHub repository, first of all, I can see that now I have two branches. The default one, we can ignore it. We have main and dev. And they contain a different description for the same subject area. So main presentation. Oh, this is the object. This one, sorry. You can see this is a dummy description. If I switch to dev, the description is different. This is a description made by Federico. Now, it's okay to develop using branches, and it's okay to have some differences sometimes, but at some point, we need to merge them together. We have multiple development teams. They are doing changes in their branches, but at some point, before going live, we need to merge all these changes together. So to do it, we start from a branch. For instance, we start from the main branch, and then we click on merge. We have to select the other branch that we want to use in the merge, in this case, dev. So I'm in main, I want to merge from my dev branch. And we can also select a strategy. There are 4 strategies available. Semantic merge will basically use the same strategy as the model administration tool used to detect conflicts. Git default is a simplified version of the semantic merge that only takes into consideration text, because behind the scenes we have JSON files. So Git default work on text. Semantic merge work on semantic model objects. And then ours and theirs are strategies which are usually to automatically fix conflicts when default or semantic merge fail. Ours will basically keep the changes of the branch that we are going to merge. Ours will keep our changes. Theirs will keep the changes in the branch that we are merging from. Now, let me use semantic merge and click on merge. Merge command failed. Why? We have a conflict. So we can double click on it, and the tool will provide an interface that actually highlight the differences between the two versions and allows us to fix these conflicts as well. So you can see that A is basically the dev branch, B is our branch, main. So we can use these switches to choose which version to keep. So if I want to keep my description, I have to disable B. And you can see that in the output, it will disappear. And then we have buttons to fix this item only, or to fix all conflicts using this strategy. Resolve item. Then this has been fixed, so I can save it. All conflicts are fixed. I need to commit the changes. And now I can properly push the repository and eventually deploy it. Okay, so this was the end of this short live demonstration. Now let me go back to the slides. And let's come back to our original question. Is it time to ditch the model administration tool? Well, it depends. If you are starting from scratch, from a completely new environment, you just started your way in analytics, and you are only using relational data sources, then the semantic modeler could be a very good option because you don't have to install any additional software, and it provides out of the box a very powerful Git integration option. If you already have a big and complex RPD where you are integrating several different sources, including EPM and SBase, then, in my opinion, it's better to continue using the model administration tool because these features are not yet supported in the semantic modeler. It's also worth noting that, according to Oracle, the semantic modeler interface will eventually replace the model administration tool. Probably not tomorrow, but in a few years, the model administration tool will disappear. So it makes sense to give the semantic modeler a try now. And the most important thing is that you can test it now and then share your feedback with Oracle. And you can see here a couple of links where Oracle development team is actually monitoring. And if you find out bugs or missing capabilities, please share them using these links, because Oracle in this way can make necessary adjustments to the tool and improve it. Okay, this completes this overview about the semantic modeler. Do you have any question?